Okay, so you want to find the order of growth of the following summations in terms of the theta notation. So we have sigma I equals 0 to n minus 1 I square plus 1 whole square. So I can expand this out as I to the power I square whole square, which is I to the power 4 plus 2 I square plus 1. So this is sigma I equals 0 to n minus 1 I to the power 4 plus 2 times sigma I equals 0 to n minus 1 I square plus sigma equals 0 to n minus 1 1. So this is uh, theta of n to the phi, this is theta of n cube, this is theta of n, right? So I can say this is theta of n to the phi. So if you have I to the 4, 0 to n, or anything n minus 1, n plus 1, and all these things, it is one more exponent, so theta of n to the phi. Similarly, this is I square, so one more than that, n cube, this is I to the 0, which is 1, right? So theta of n. So we'll try to use the same approach here. We have sigma equals 0 to n minus 1, j equals 0 to I minus 1, I plus j. So let's do the inner summation. So I equals 0 to n minus 1 stands out as it is. So I basically take the summation inside. So sigma j equals 0 to I minus 1 I plus sigma j equals 0 to I minus 1 j. So now here you see here in this summation I is actually a constant. So I can say take this I outside and say this is sigma j equals 0 to I minus 1 1. So now I can apply my upper limit minus lower limit formula. So it's I minus 1 plus 0. So I minus 1 minus 0 plus 1. So that is I. So it's I times I square for this term, and this is j equals 0 to I minus 1 j. So I can say it is j, you see this is like I is n and j is like your I, so I can say this is like I minus 1 times I minus 1 plus 1 over 2. So I can say it is I minus 1 times I over 2. So it's I square minus I over 2. If you take the LCM, so it's going to be 3 over 2 I square, LCM between these two, minus I over 2. So either way you can say this is theta of n cube minus this one is going to be theta of n square. So I can say this is theta of n cube. Okay. Then okay, so for this so if you want to analyze the complexity of this, sigma I equals 0 to n minus 2, j equals I plus 1 to n minus 1, and we do one comparison. This is the basic operation here. So the way to look at that is this, right? So sigma equals 0 to n minus 2, j equals I plus 1 to n minus 1, right? And we do one comparison for every execution of the j loop. So now I can apply my upper limit minus lower limit formula. So outer limit summation stays as it is, sigma equals 0 to n minus 2, n minus 1 minus I plus 1, the lower limit, plus 1. So it's n minus 1 minus I minus 1 plus 1. So the minus 1 plus 1 cancels, so it's n minus 1 minus I. So now I can substitute the values of I equals 0 up to n minus 2. So it's n minus 1. Okay. So I can substitute it to be something like this: n minus 1 minus 0, right? Just then n minus 1 minus 1, so that's going to be n minus 2, then n minus 1 minus 2, so it's n minus 3, so on up to n minus 1 minus n minus 2, right? So that's going to be n minus 1 plus n minus 2 plus n minus 3, so on up to 1, because this is n minus 1 minus n plus 2, so that's going to be a 1. So that's going to be 1 plus 2 up to n minus 1, so it is n minus 1 times n minus 1 plus 1 over 2, so it is n minus 1 times n over 2 such that of n square. Okay. So this is a unique elements, it's the same thing. Okay. In terms of analyzing the time complexity. Now developing an theta of n log n algorithm to determine whether or not the elements of an array are unique. So one way to do that is just sort the elements of the array, and sorting takes n log n time, right? And then just compare, go do a linear scan of the array and check if the elements in the subsequent indices are the same or different. Okay, so a linear scan takes theta of n time, and you are doing a comparison every time as we go through the array. So it is theta of n log n plus a theta of n, so that is theta of n log n. Okay. Now for the largest element in the array, all we have to do is we have to again pick the first element as the temporary maximum, and then go the rest of the array and check if we encountered something that is greater than the current maximum. So if we encountered something that is greater than the current maximum, we can set maximum element to be that particular element. Okay, so the summation is going to be sigma I equals 1 to n minus 1 comparison for each iteration of the I loop. So it is going to be upper limit is n minus 1 minus lower limit is 1 plus 1, so it's going to be n minus 1. So it's going to be upper limit is n minus 1 minus lower limit is 1 plus 1, is going to be n minus 1, that is theta of n. This is for the matrix multiplication.